Okay, so let's move now on to the what is known as the related rates of change. Okay, section. Sometimes you kind of think about this as using your chain rule again, which is multiple derivatives being multiplied or divided to get a second, third, fourth derivative function rate of change. So we want to know at what rate is the radius increasing when the radius is 8 centimeters. Okay. So we're given here a rate of change. So this is centimeters cubed. So that's going to be the derivative v. So the rate of change of the volume, and it says per minute, so it's with respect to time. So the rate at which volume changes with respect to time. The one it's asking for here, the rate at which the radius is increasing. Okay, and what that means is it wants us to find the rate, the dr, so the rate at which the radius is changing. It says when the radius is 8, don't be confused here. If it says the rate and it's a bit vague about what it's changing with respect to, it's probably time. So the rate at which the radius is changing with respect to time. Normally, if it tells you a number like this, that'll be the thing at the bottom, that'll be the variable, but these kind of change questions are a little bit different. So we need a third rate of change, and my assumption is this one will be given you in the question. I'll tell you why I think that is in a minute. And it's knowing the volume of a sphere is 4/3 pi r cubed. Now I've been having a look. This is a document you can find on Moodle, which is from AQA, and it's about formulas that you need to know. And if you look in here under the geometric mensuration kind of thing here, it never mentions about any kind of volumes of things like this. So presumably you need to know area is pi r squared, but you don't assume to know volume is 4/3 pi r cubed. So presumably that's one they'll give you if you need it. And from that, if we differentiate this, we'll get dv over dr, which is that third rate of change we'll need, and that will be 4 pi r squared. Never quite figured out if this is a coincidence it's the surface area of a sphere. I don't think it is. I think that's to do with how rates of change and stuff work. Anyway, so we need dr over dt. That's what we're looking for at the end. So we need that to equal two of these things, either multiplied or divided. Okay. And if I'm going to multiply them, I'm going to have to flip this one upside down to be dr over dv. We can do the reciprocal of that. And if we multiply that by dv over dt, we'll have the two things we want on top and bottom, r and t, and these two on the diagonal, which will effectively cancel out. Okay. So dr over dt for this question is going to be the reciprocal of this, so 1 over 4 pi r squared, times by dv over dt, which is 200. Since this, yes, that's constant rate as well. And then all we need to do is substitute in the value we're told, which is 8. So this is when r equals 8, and then calculate this, which will equal 1 over 4 pi times 8 squared times by 200. Okay, which means for this question, our dr over dt, when r equals 8, is going to equal to, grab my calculator. And you can do this as one fraction or one fraction times by one kind of whole number. Doesn't really matter, it'll give you an equivalent thing. So 1 over 4 times pi times 8 squared, and then all that times by 200 is going to give me 0.249, and it's radius at centimeters per second. And they've written theirs in words, so I'll write mine as centimeters per second in words. Per minute, sorry. Going very mechanically there and assuming, but that's per minute. Okay, guess that or kind of technically work, but as I said, they've used minutes, so I'm going to use minutes for increasing as well. So the rate at which increasing is 0.249 centimeters per minute, and that's it. Something we're given, something we need, and something else, either something from a shape or something like that. Could be something different, I suppose.